Hello, good evening friends. Today I am going to explain the problem on the basis of second law of Faraday. Faraday's second law of electrolysis. Let us see what the problem is. The problem they are saying that is a current was passed for 6 hours. A current was passed for 6 hours through two cells connected in a series. 8.28 gram of gold was deposited in the first cell and some copper from the copper sulfate solution in the second cell. If the oxidation number of gold is plus 3, find the amount of copper deposited on the cathode in the second cell. Okay, this is a very simple type of problem. Okay, so what they are saying that is two cells are there connected in the series and 8 hours you are passing the electricity. So 8.28 gram of gold is deposited. So here the things they have given, the important information, that is for gold they have given n factor they have given, and they are saying that is 8.28 gram of gold is deposited. So they are asking that is amount of copper deposited, and we know that if something is connected in series, so we will apply the Faraday's second law of electrolysis. And Faraday's second law of electrolysis saying that is if the same amount of electricity pass through the different electrolytes, then the amount of substance deposited will be proportional to the equivalent weight of that substance. Now we are applying the Faraday's second law. So weight of the gold deposited equal to equivalent weight of gold, and weight of the copper deposited equal to equivalent weight of the copper. Now they are saying that is amount of two cells connected the series. 8.28 gram of gold was deposited. So 8.28 gram by copper, weight of the copper, equal to what we have equivalent of the gold they are saying, and here they have second, that is the oxidation number of gold is 3. Oxidation number of gold is 3 means n factor. N factor is 3. So equivalent weight means what? Molecular weight. Molecular weight upon n factor. Molecular weight they have given 197 gram and n factor is how much? 3. So here is what? 197 upon 3. Then weight of copper deposited equal to equivalent weight of copper, that is equivalent weight molecular weight upon n factor. Molecular weight given 63.5 divided by n factor. N factor copper valency we know that is from the copper sulfate. If you are ionizing copper sulfate, it will give what? Cu2 plus SO4 2 minus. So here copper 2 plus n factor equal to 2. So molecular weight upon 2. Now 8.28 gram by copper equal to 197. Here the rearranging this. So 2 will go up, 3 will come down. So it will 197 multiplied by 2, 63.5 into 3. So here if you are calculating here, so after rearranging you are getting 1577.34 upon 394, and after calculation you are getting that is 4 gram of copper. So if you are passing 6 hours of electricity, so the amount of copper will be deposited will be that is 4 gram of copper will be deposited, and for the gold they have already given. So this is the simple question based on Faraday's second law of electrolysis, and that's Faraday's second law of electrolysis already you know, that is if the electrolytes are connected in the series, then you are passing same amount of electricity in the all the electrolytes, then the amount of substance deposited will be proportional to the equivalent weight. So equivalent weight we already know that is molecular weight upon n factor. N factor is nothing but valency factor or the oxidation state. So here we know that is molecular weight is given 197, n factor oxidation state plus 3. So 197 upon 3 and 63.5 upon 2. For copper sulfate, n factor for copper is 2. So after calculating, putting the value in the Faraday's second law, copper you are getting 4 gram. So that is amount of copper deposited will be how much? 4 gram. Thank you so much for watching friends.